From okay. Do I have to record also, or can I do away with it?
I hope nothing goes wrong and I just record the whole thing.
Yeah. Why don't you record also? Just in case.
I'll try, but
You-
I have no
okay.
facilities.
Okay.
Okay. So make
Oh.
it co-host.
I did make it. Oh, you mean second time? First you join. Let's see. I will record also.
Oh, so that's good.
Let's see. Come here and make sure that I'm not making a mistake. Record on this computer. Yes. Record on this computer.
Yeah.
Record this meeting to the computer. Continue. Yes. Okay. Now we are, I think, suitably set up. Okay. First, I want to talk about the exam. First, I want to talk. I have graded all the exams, and I had initially thought, no, I recognize you quite well, with no problems at all. What was I going to say? Yeah, I was going to talk about the exam. The exam, I want to say a few words because it seems to me that people copied properly. How much they understood is not clear. First of all, I want to make one point about a curved object. If you want to prove that something is not flat, the strategy I had the whatever color was the beard, orange or yellow, the one that
Was orange.
it was orange. Okay. Mr. Orange Beard, I had him do the following. Choose 2 points on the curved object and then compute the midpoint. If the midpoint is not on the curved object, then it clearly isn't flat. The definition of flat means, what happened?
There is a loop, as one of the
Oh,
machines are practical money, like here it is.
oh,
Okay, it's just a small.
that's wrong. Something happened here.
Yeah, no,
You are sharing screen, I know that.
No, it wasn't you. It was over here, because I think it was one of those. It was coming through, maybe no one else ever.
Yeah, I can like turn it down.
Yeah.
All the way down.
Yeah.
It won't let me.
Okay. Where's the screen?
That should be good enough, this is all the way in.
Okay.
Okay. Okay. So what I was going to say,
You could just turn off the microphone for here.
it was off. Oh,
Whatever y'all did made it worse.
okay. Is it better now? Oh, no.
Oh, turn off the speaker.
Where? Here?
Yeah.
No, it's not turned on. You mean reduce it? Yes.
Okay.
Okay.
Is
Is it better now?
Not
be heard?
really. It's still like echoey. It was fine for me at first, but then whoever just made changes within the last like 30 seconds and made it
Okay.
worse.
Yes.
Yeah.
That's what I was.
Okay.
That's better for me.
Yeah, that's much better.
Are things working now?
Yes.
Can you hear me?
Yes, I can hear you.
Increase the volume. I don't see how to do that. There's some problem. What happened to the volume button? This one. This doesn't scroll because it's just 1 minute.
Oh, it's here.
Yeah. volume up. Can you hear me now?
Yes, I can hear you.
Okay, good. Now let me go to the full screen mode. Okay. Okay, so what I wanted to say is the following. The idea of flatness amounts to the following, that if you choose, if 2 points are given on the, 2 arbitrary points are given on the object, if you draw the straight line through them, the entire straight line would lie on the object. For every pair of points, this is the case. So that means in order to prove that something is not flat, all you have to do is to find 2 points, join them, and show that their midpoint is not on the object. This is the strategy that was used. Okay. The second thing I wanted to say is that this is enough to show that something is not flat. However, suppose you have a cylinder and you choose 2 points such that the entire line lies on the cylinder. So then you are out of luck. It doesn't prove that it is flat. It just shows that for that particular choice, the line happens to lie on the cylinder. In fact, you can have something even like the hyperboloid of one sheet, which has a family of 2 families of straight lines actually on it. I mean, these are seats which you must have seen, made of wickerwork, for example. So these are the 2 families of straight lines that lie on the surface, but the surface is not flat. Okay, so you can have a curved surface on which you can have an infinite line. In fact, it's a very peculiar theorem that on any cubic surface whatsoever, a cubic surface is one that is described by a cubic in 2 unknowns. So z is equal to a cubic polynomial in x and y. On such a surface, there are always 27 straight lines. It could be the case that it's a degenerate cubic, in which case the sum of the 27 actually collapse. Okay, but collapse meaning that you may have to count certain straight lines more than once. But this is a very strange feature of a cubic. Okay, and it's not terribly easy to prove. Okay, so that's the first point. The second point is that no one ventured much beyond the A's and B's, except to say that there are 2 equations, and therefore it has the right dimension. But of course, no one bothered to say that the 2 equations were independent because they were of different degrees. So I should have given 0 on that feeble attempt, but I didn't. People filled in the blank that I had, but they didn't bother to say that the equations were actually independent. Is this clear to everyone?
Yes.
What people filled in didn't say that the equations were independent. Yes. So you have to say that the equations are in fact independent before you can conclude that the dimensions behave properly. Okay, so that's the first part, but other than that, people more or less did it correctly. I will note that 1C and 2A are missing, the solved exams. After looking at this exam and the complete success on the part of most people to get 36, I decided that I will not write the solutions of 2A and 1C, but I will discuss the exams in detail and I will let you do it. You have seen enough of the way in which the work has to be done. Neither exam is terribly difficult. Yeah, 2A has to do with line integrals, which is very easy, and 1C has to do with extrema and Taylor's theorem, which are basically a pain in the sense that there are hundreds of millions of cases to consider. And that is one of the reasons why Mr. Orange-Beard gave up, out of sheer boredom. Mr. Orange-Beard. Someone who has an orange beard. It could be done with mehendi, for example. After one's hair has become white. Incidentally, my hair are all green. It's vacuously true because I have no hair at all. They are also all red.
Also, yeah.
Yes. And also made of snakes. So any universally quantified statement about my hair is vacuously true because I have none.
Yes.
Yes. No. Only on the top of my head. I'm using a little euphemistic reference. Okay. So what am I going to, yeah. So this finishes this part. So now I have what? You can't say if it is no non-existent hair, that means that my hair actually does exist. That's false, yes. But that's not a universally quantified statement. The statement that means that I made that for every hair on my head, it is the case that it is blue, it is green, it is white, it is clear, it is 5 million miles long. Yeah, so, no, even for, I mean, any statement will be true. If I say for every hair on my head, T, that's a true statement. For every hair on my head, falsehood, that is also a true statement. This doesn't make any sense. You have to say it within the right language. Okay. Let's see. The last problem, which no one did, which is 3C, which is to parameterize a three-dimensional bounded object, will come to haunt you when you do the integration in later parts of the course. Because there are problems in which there's a problem in which you have half a mind to make it a little more complicated. There's a sphere with a donut-shaped hole in it inside. So this would be, suppose you do the following. Yeah, well, how can you get this to work actually? Okay, you make an actual donut, you make the donut out of sugar. You take some dough and make a ball out of dough around the donut. Okay, and then boil it in water. If you boil it in water, this sugar will dissolve. And therefore you will be left with a solid object, which looks like a sphere and which will have a donut-shaped hole in it. You could, but this is easier. Yeah. Anyway, so this is the object over which you have to integrate, but I did it in such a way that the answers turn out to be very easy. So maybe I should alter the vector field a little bit to make it a bit more painful. But I will decide that.
Professor Bakshi,
Yes.
I had two questions, if I may.
Yes.
Just to recap what you said earlier, so no solved exam will be given for 1C and 2A because you think that we can do it.
Yes.
Okay. Also,
I mean, but after you have been, what should I say, relieved from guinea pig hood, your exams will be used after coloring the beard a certain suitable color for posterity.
heard. For my other question,
Yeah.
do you happen to have an answer for that email I sent you a while back about exam 1B?
Exam 1B. Just a moment. I must have written an answer and not forgot. I must have forgotten to press send because I remember having written something. But remind me of the question once more.
So the solved exam makes changes to the actual question being asked for, I believe it's question 3A and 3B.
Yeah, I will give a look. And your question was whether you have to make a similar change.
Yes.
Okay, I will have to go and look. Actually, I don't dare do it now because I may mess up the setup that we have. But can someone give me, let's see, may I have a look at question 3 and 3B on your computer right now?
Oh, you
So what happened when-
Yeah, I showed on the iPad here.
No, don't. Oh,
I know,
Okay, okay,
I still
yeah.
have the notes. Here we go.
1A, no, 3A, question on 1B.
It was
Oh,
on
right.
exam 1B, question 3A and 3B, I believe. But you have to go to the solved exam.
Show me the solved exam and let me see.
Okay. Solve exams. 1B. There you go.
1B, question 3A. Let me see what question 3A is. Two B, 3A. No, you do not have to make that change, at least on 3A. The reason for changing 3A to that one is so that the problem is sufficiently different from yours. Riviera, did you understand?
I do, thank you.
Okay, and 3B, I suppose the answer is also no, but let me have a look. Yes, the answer is also no on 3B.
Thank you.
Okay. Okay, but but there is something that I need to explain over here. It's it says from k is equal to 1 to cyclic. Cyclic means the following in this case. So if you have, let's say, 3 unknowns, it would be x1, x2 plus x2, x3 plus x3, x1. If you have 4 unknowns, it would be x1, x2, x3 plus x2, x3, x4, sorry, x1, x2, x3 plus x2, x3, x4 plus x3, x4, x1. That means you go through the indices cyclically.
Okay,
Okay, so if you have 5 of them, so you would have 1, 2, 3, sorry. Sorry, I made a mistake because I was not looking at the problems. You take them in pairs, right? So that's why the second example was wrong. So if you have 3 indices, it would be 1, 2, 2, 3, 3, 1. If you have 4 indices, you would have 1, 2, 2, 3, 3, 4, 4, 1. If you have 5 indices, 1, 2, 2, 3, 3, 4, 4, 5, 5, 1. Yeah. Yeah, consecutive, and the last one must come back to 1. That's the idea of cycling. Clear?
yeah, thank you.
Okay. But the question that is important is to understand what the object should look like, what the constraint is. So, but let me see what are you supposed to do. Yeah, if you want to say that it is not, if it is, so I deliberately did not define what it means to be connected. So for instance, oh, can you change this? Yeah, so that I can go back to. No, not this one.
Yeah.
Okay, so suppose I have the set of all xy in R2 such that x squared plus y squared is equal to 1, right? We all know what it looks like. So I should respect. What I don't like about this is that it's a bit slippery. It's friction. Can you change the?
I've been using it for more than a year.
So you are used to slipping, whereas I am not. X, Y.
Press your hand on this display.
On the display. Where is the display?
Put your hand flat on this, like your palm.
Yeah.
First, place it on the display.
Yeah.
Don't respond,
How is it going to make the friction more?
because your hand will be the friction area here instead of.
No, but that will not improve the control over the tip of the pencil. There must be a way to set the friction.
The only way to change friction is to change the physical temp for it, so you can keep flow opposite fits.
No, I don't they have some sort of a haptic feedback control in which you can adjust?
It wouldn't do anything with the friction. We actually
Okay.
physical friction.
Anyway, so this is a circle that is in one piece, that's connected. Whereas if I have this set, the set of xy in R2, such that xy is equal to 1, the graph in this case is in two pieces, so it is not connected. Okay, so the reason why I asked you to buy the mathematical handbook, because if you have a hyperbola given by this equation, it looks like this. Okay, now I have two possibilities. I can rotate it about the y-axis, and that would give me a picture like this, which is a hyperboloid of one sheet. But on the other hand, I can rotate it about the x-axis, in which case I will get something like this. This is a hyperboloid of two sheets. Okay, so this is not connected. That means this is not in one piece. This is in one piece. Huh? Sheet and shell? Shell we have never used. The word shell. One sheet in this case simply means refers to the surface. The technical word is connected. So the difference between these two is that if I draw any 2 points over here, I can go from one point to the other by a curve that lies entirely on the surface. If I take these 2 points, I will not be able to do this. I will have to leave the surface to not to go to the other one. Is this clear to everyone? So but it's tricky because if you are given any 2 points on the object, you have to show that there is some curve lying entirely on the surface that would go from the one to the other. But no one is going to tell you where the curve is. Yes, so that's not at all easy. Or if you suspect that the thing is not in one piece, you have to have enough of an idea of how it looks like so that you know which 2 points you must choose to show that there's, in order to go from one to the other, you will have to leave the surface. That means on any curve whatsoever joining those 2 points, there exists at least one point which is not on the surface. Is this clear to everyone? Riviera? Riviera has disappeared?
Yep, I'm here. Hello?
Oh. Yes,
Somebody wanted the Zoom link, so I'm trying to give them the Zoom link so they can join.
I see, okay. But you understood what I said?
Yes.
Okay. Did you finish giving the guest the Zoom link?
Yes.
Okay, so there's a musical analog of this. The musical, can you tell me what the musical analog is?
No.
Analog.
Um,
What is the musical analog of a curve joining one point to another?
I would guess a scale.
No. A continuous path from one point to another?
A song?
No. No. Okay, so I will give you a hint. You will have to give me the technical word. So a note is defined by frequency.
Yes.
Frequency. So if I choose 2 distinct frequencies, and if you have to connect from one of them to the other without breaking, what is such a thing called? So automatically this is impossible on the piano, which is taken to be the ideal, because you jump from one frequency to another. the stringed instruments and the voice are not are not discrete as the piano.
Are you talking about vibrato?
No,
Or are you talking about harmony?
neither. What happens if you allow the voice or the what happens if you glide from one note to another? What is that called?
A glissando.
Yes, a glissando. Yes, that's from the Italian word meaning to slide or to glide. Yeah, so the not being able to connect two would be the impossibility of doing a glissando from one note to another. So the piano automatically.
So glissando's a little bit different, but like that's a slur, I think, is what you're talking about. Connection between one note to another, and staccato would be space between those notes.
Yes, the slur in a way, yes, but even a slur, I mean, the slur is, to my understanding, used for stringed instruments and not for the voice.
No, a slur can be used for any instrument. It just means that you're supposed to play the notes together. Like it's supposed to be a phrase of sorts, whether that's like a small phrase just between two notes themselves or.
Yeah, except for the fact that all frequencies are to be used whether or not they occur on the piano. That's the point. So if you have a slur mark on, let's say, a bunch of notes, for instance, something like this, without saying what the scale is, this. That's, I think, the notation for a slur.
Yes, that's correct.
Yes, but that is not what I meant, because in this case, I'm still identifying discrete frequencies in between. This one is not allowed to do.
So
In the analogy,
a piano can do a glissando, but it doesn't include everything, right?
yes,
But
that's
they
what I'm-
technically can do a glissando.
Yeah, I wouldn't call it a glissando, strictly speaking, even though it is referred to as such, because of what I just said. Because it is incapable of producing all the frequencies in between. And an ambulance gives you very good examples of what should be a glissando. They're not pleasing to the ear, but that's a different story altogether.
Yeah.
Okay. So, so you will have to think. So this is a problem for Rivera to handle separately in his own free time. That is, think of instruments that could produce a situation in which it is physically impossible to execute a glissando from one note to another. And I am not ruling out the possibility of four-dimensional drums or instruments in which the half an hour mark, instruments in which rather than strings you have surfaces. No,
So there's also the trombone, which has a slide, but that can produce a number of frequencies. Not all of them, but a number of them. Like even the human voice can't produce all the frequencies possible, right? But can produce a good number of them.
No, it's continuous. I mean, in other words, we have to be careful about what we mean, because the question is whether the distinction is to be made by the ear or by some instrument. That's the question. So I would be happy with something which is analogous to what I'm doing on the screen, because, I mean, what I'm drawing is hardly a continuous curve, right? And it is an approximation there. They on the screen. I mean, if I draw this, right, that is, I mean, that is still a bunch of discrete things because there are pixels after all. Yeah. No. I set this problem so that one can think of a situation in there are two frequencies, and using the instrument that you have or the voice, you cannot join one to the other.
Two notes.
Yes, without it is physically impossible to produce all the intermediate frequencies. Whereas, for example, if I think of a slide done by the voice from one note to another, I will take that as an approximation to a continuous curve in frequency space between the two notes. Okay. So the human voice can do very strange things, and instruments like four-dimensional drums would also do very strange things. No, I mean, I'm not going to tell you the answer. You will have to think of this. So I gave another example of a peculiar thing where rather than strings, you have two bridges, but connecting them are two-dimensional surfaces. Not, yeah, suppose you take something like a guitar. So there's a wooden thing over here, and there's a bridge over here, and there are strings stretched across, or in the violin, that's the case. But in between the bridges, rather than strings, if you have sort of flat tapes, that would, but it has to be done in such a manner that it actually produces proper sound. Okay, so there I will leave the musical analogy. So now, the question that I have to deal with is the question of the chain rule. Okay, the chain rule comes in two different varieties. One that you should know, because if you are in engineering or physics classes, your teachers will kill me if I don't teach you the rough and ready method for the chain rule. Chain rule. The chain rule. So I will give you the general scheme, and I will also give you the specialized scheme that is of use to physicists and engineers. Okay? So the general scheme is as follows, and it's good to do a particular example. Suppose I have this situation. X1, X2, X3. This is beta. This is alpha. This is, what shall we call this? Y1, no, Z1, Z2. And here I will have 1, 2, 3, 4. Y1, Y2, Y3, Y4. So alpha is a function that sends Z1, Z2 to something. Let me write it this way. Y1 is equal to alpha 1 of Z1, Z2. Oh, this is very bad. I will have to use more lines. So let me make this Z1, Z2 going to Z1 plus Z2, Z1 minus Z2. From, is that good? No, that's wrong. Yeah, this is a bit too narrow. No, that's okay. That's okay. I will write it this way. I will make it Z1 plus Z2, Z1 minus Z2, and Z2. And this is from R2 to R4, which means that Y1 is equal to alpha 1 of Z1, Z2, which is equal to Z1. Y2, which is equal to alpha 2 of Z1, Z2, which is equal to Z1 plus Z2. Y3 is equal to alpha 3 of Z1, Z2, which is equal to Z1 minus Z2. And Y4 is equal to alpha 4 of Z1, Z2, which is equal to Z2. Okay? Clear? So now, what is the other one? Beta. Okay. Beta will be defined to be X1, how many? Is it X1, X2, X3? Going to two of them, right? R3 to R2. So R3 to R2, right? R3 to R2, yes, no, R2. Yeah, yeah, so I will make this x1, x2, comma, x2, x3 from R2 to R3, which means Z1 is equal to beta 1 of x1, x2, x3 is equal to x1, x2, and Z2 is equal to beta 2 of x1, x2, x3 is equal to x2, x3. So far, so good? Okay, so it's good to write down what happens. 3, this is beta, this is alpha. Okay, so if I feed in x1, x2, x3, I get x1, x2, x2, x3. Here I get, well, alpha gives you 4 of them, right? So here I get x1, x2, here I get x2, x3, right? This is Z1 and Z2. Neither you nor I can see the whole thing, making it very difficult. So this is x1, x2 plus x2, x3. This is x1, x2 minus x2, x3. This is very dangerous because if I can't see the whole thing, I will not be able to catch my mistakes.
Like have the whole thing, like make it a bit bigger.
No, it's still going to be problematic. What do you mean?
That's the opposite. So it's,
Mhm.
you know,
Oh,
you
That's-
won't be able to see everything at once. So
Yeah,
it's just
but
everything's
see,
small,
if
like-
I can write from there to here, I can see what happened several boards ago. That is not possible over here, but anyway, we shall try. Where was I? So alpha composed with beta. Just a moment. This is this. Okay. Do I want to say that? Yes. Alpha composed with beta.
this is similar to what we did last week, right?
Yes. X1, x2, x3, but there's a very important point over here. Going to x1, x2, x1, x2 plus x2, x3, x1, x2 minus x2, x3. This is all worked out in a note in the notes with some example which I cooked up at the time. I have no, while I was in quarantine, I have no recollection whatsoever of what it is, but it will always work. Okay, so alpha composed with beta, sorry. Z1, not Z1, Y1. Y1 is equal to alpha composed with beta 1 of x1, x2, x3 is equal to x1, x2. Y2 is equal to alpha composed with beta 2 of x1, x2, x3 is equal to x1, x2 plus x2, x3. Y3 is equal to alpha composed with beta 3 of x1, x2, x3. Incidentally, I will repeat that since I don't read my own notes, the notation over here may differ from what it says in the notes. But do not take this as the correct one, take the one in the notes as the correct one. Okay, because I have never looked at notes, so I mean, I may not be able to remember exactly how things are. In fact, I'm not even trying to. I'm just giving you a consistent. It's unlikely that I will change the notation because I've used it for a long time. So Y4 is equal to alpha composed with beta 4, x1, x2, x3 is equal to x2, x3. So now I have to find the derivative at an arbitrary point x1, x2, x3 of alpha composed with beta, which is also written as d of alpha composed with beta at x1, x2, x3. Incidentally, on the exam, x1, x2, x3 could be numbers, particular numbers. Okay? But I'm going to show it in general. So this is equal to, and now I will have to, this is going from where to where? So just one. This map goes from, so I will calculate this, but before that it is useful to write down where it belongs. So that will be on this side, which is, just to remind ourselves, d of alpha composed with beta at the point x is in the linear maps from where to where? It goes from R3 to R4, right? Okay, which means that it has to take an input of 3 elements and produce an output of 4 elements, which means that this is equal to del 1 of alpha composed with beta 1, del 2 of alpha composed with beta 2, del 3 of alpha composed with beta 3, del 1 of alpha composed with beta. Is this right, or is this, have I mixed it up? From,
Yeah, this looks like it's right, about the 2 there.
no, compared to last time.
Yeah, last time.
This is what I did, right? Del 2 of alpha composed with beta 2, del 3 of alpha composed with beta 3. Now alpha composed with beta has 4 or 3 of them.
The last one would be 2.
The last one should be 2, yes. This one is also wrong.
Yeah, the topper is also wrong, so we got 2 and 3 again, so 1 and 1.
This is, should be 1. So this should be 1. And this should be 1. Oh, this. Okay. Del 1. Alpha composed with beta 3. Del 2. Alpha composed with beta 3. Del 3. Alpha composed with beta 3. Del 1. Alpha composed with beta 4. Del 2. Alpha composed with beta 4. Del 3. Alpha composed with beta 4. Okay, so now you will have to tell me what these are. Del 1, what is alpha composed with beta 1? I've forgotten. X1, X2. X1, X2. Del 1, what is alpha composed with beta 2? X1, X2 plus X2, X3. Del 3, del 1, X1, X2 minus X2, X3, right? And del 1 of X2, X3. Then del 2 of the same thing, del 3 of the same thing. Del 2, del 2. Sorry. Del 2, this is del 3. This is del 3. This is del 2. This is del 3. This is del 2. This is del 3. Okay, so this is equal to, if I'm doing things correctly, del 1, this is x2. Del 2 of x1, x2 is x1. This is 0. del 3 of, it doesn't depend on 3. Okay, so del 1 of x1, x2 plus x2, x3 is equal to x2. Del 2 of x1, x2 plus x2, x3 is x1 plus x3. Del 3 of that is x2. Here I will have del 1 of x1, x2 is x2. Del 2 is x1 minus x3. Please ignore that. Del 3 of that is equal to minus x2. Del 1 of x2, x3 is 0. Del 2 of x2, x3 is x3. Del 3 of x2, x3 is x2. Can you check that this is correct? Because I can't really see what I'm taking derivatives of. x2, x1, 0. x2, this one should be x2 also. This one should be minus x2. This is x2. And here I should have x2 plus x3. Here I should have x2 minus x3. This is 0. This is x3. And this is x2. And it has the correct kind of symmetry. Okay. So this is where I take the derivative after composing. But now I have to do the other thing. That is, take the derivatives first and then multiply. So this is very important. For linear maps, composition amounts to multiplication of the corresponding matrices. So the matrix of a composite linear map is the product of the two matrices. Okay, so now several screens earlier, we computed, or we didn't compute, we defined alpha and beta. So alpha is this Z business. Okay, so alpha goes from where to where? Alpha is a linear map from R2 to R4, right? And D, Z1, Z2, which are the inputs of alpha, is equal to D alpha at Z1, Z2, which is equal to, okay, so there are two. Del 1 in this case refers to the Z1 of alpha 1. Alpha has 4 components, alpha 1, alpha 2, alpha 3, alpha 4. So this would be del 1 alpha 1, del 2 alpha, alpha 1, del 1 alpha, del 2 alpha 1, del 2 alpha 2, del 3 alpha 1, oh, I wrote alpha 3. Del 3 alpha 1, del 3 alpha 2, del 3 alpha 4, del 4. No. What nonsense have I written down? This is, let's see, these are all wrong. Let's correct these. There's no del 3. So this is 1, 2, 1, 2, 1, 2. Incidentally, if anyone has insomnia, teaching them the chain rule works infinitely better than any sleeping pill. The only person who will not fall asleep is the person who is doing this and trying to get it right. So del 1, these are both alpha 2s. These are both alpha 3s. These are both alpha 4s. Okay, so now I will get everything wrong unless I write them correctly. What were the two functions? I've forgotten long ago. Z1 went to what and Z2? It's Z1 plus Z2, Z1 minus Z2, and Z2. Okay. So Z1 plus Z2, Z1 minus Z2, Z2. And this is del 2 of the same things. In this case, I might write them down. Z1 plus Z2, Z1 minus Z2, and Z2. Okay, so the derivative is going to be what? 1, 1, 1, 1. Oh, 1, 0, sorry. 1, 0, 1, 1. 1 minus 1 and 1, 1. Note that the derivative of alpha is a constant. Why is that? Because alpha happens to be a linear map. Okay, because note that in the outputs of alpha, you do not have any powers. Okay, so alpha is actually a linear map, so that's why its derivative is a constant. That is why okay, so no matter at which point you take the derivative of alpha is going to be constant. Not so for beta, because beta is not a linear map. So delta D, beta is a map from R3 to R2. So D beta is a linear map from R3 to R2, right? So D at the point x1, x2, x3 of beta is equal to D beta at the point x1, x2, x3 is equal to del 1, del 2, del 3, del 1, del 2, del 3. Beta had how many components? Beta had 2 components because it went from x1, x2, x3 to x1, x2 and x2, x3. Let me see if what I'm saying is correct. X1, yes, x2, x3. So I should write, no, I made some mistake. Beta should take a thing with size 3 and yield this thing with thing size 2. That's correct. So there are 3 derivatives, but beta is going to 2. I'm making a mistake here. Oh, yes. No, beta, derivative of beta goes from R3 to R2, right? It's a linear map from R3 to R2. So it should take an input of 3 things and give you an output of 2 things. But what is the mistake that I made? The derivative is of the wrong type. There are 3, but there should be 2. So if I put x1, x2, x1, x2, x1, x2, and x2, x3, x2, x3, x2, x3. So that gives me x2, x2, x1, 0. And this would be 0. Oh, this is not 0. This is del 1 of x2, x3 is 0. Okay. And this should be del 2 of x2, x3 is x3. And what is del 3 of x2, x3 is x2. Yeah. So this is the derivative at the point x1, x2, sorry, x2, x1, 0, 0, x3, x2. So what is the derivative according to the chain rule of alpha composed with beta? So this is equal to derivative of alpha derivative at the point beta of x1, x2, x3 of alpha times the derivative at the point x1, x2, x3 of beta. So note that this point has to be transferred by beta to the over there. So this is equal to the derivative of alpha was a constant. So that was a matrix. Where on earth is it? Derivative of alpha is a constant. Yeah, so that is 1, 0, 1, 1, 1 minus 1, 1. Oh, that cannot be right. There has to be 0. Del 1 of Z2 is 0. So I made a mistake here. Del 1 of Z2 is of course 0. So this is 0. Yeah. So 1, 0, 1, 1, 1 minus 1, 0, 1. Oh, 1 hour is over. 1, 0, 0, 1, 1, 1, 1 minus 1. What is the derivative of beta? x2, x1, 0, x2, x1. Ah, they're not of the same size. I made a mistake. I think this is on its side. Was it beta composed with alpha or alpha composed with beta? Yeah, this is the problem with this sort of thing because I can't see, and since I'm 3 to 2, so I would get, just let me make a note to myself. This map will be 1, 2, 3, 4, 1, 2. So it should take in something with, so it should look like this. It should take in 2 things as an input, but give you a 4 things as an output.
Oh, you changed it. Wait.
Those 3 things as an input.
No, alpha.
Oh, alpha. Oh, 2, 2, 4.
2 to 4, right?
Yeah.
2 to 4. Alpha will give you 2 to 4. So let me draw this slightly. Yeah, alpha should give me 2 to 4. So alpha, so this is an aside, alpha gives me 2 to 4. And I believe that's what I have over here. One of them is wrong. Alpha is 2 to 4, so that's correct. What will beta give me? Where did I draw? Yes. Beta should give me something from it should take in 3 things. So it should look like this. This is beta, right? This is the derivative of beta. Screen broadcasting, what does that mean? Just say okay. Go to application. Okay.
Oh, wait. Did we cut off earlier? Oh, I think I disconnected for some reason.
Okay.
Internet.
Just a moment. Yeah.
It disconnected from the Wi-Fi.
Yeah, so it's connected again.
Oh, could you make me co-host again?
So participants make co-host on both of them,
Just one. The one with the profile picture. Yeah, that one.
that one.
Yeah.
Make co-host. Yes.
Right.
Okay. I am back again. Yes, so is the derivative of beta that is wrong in what I calculated. So this should be 1, 2, 3, but beta 1, beta 2. But I thought I did that. One, two, three. Yes. So this is, of course, wrong. So this is wrong. So I will have to erase this. Oh. The derivative of beta was calculated incorrectly. So all of you are asleep. That is absolutely clear. I don't blame you because, as I said, that this is infinitely superior to a sleeping pill. So it should be 1, 2, 3. So del 1, del 2, del 3 of beta 1, beta 2.
Beta one, beta one.
Beta 1, beta 1, yes.
Not beta two, beta
No. Something, I mixed up some convention here.
one.
So if it actually works out, it will be an absolute miracle. And you should take this with a large grain of salt because I am blind over here. I can't see what I was doing earlier, and therefore it is very likely that what I have is wrong. So this is del 1. What is beta 1? X1, X2? X1, X2, and beta 2 is X2, X3. Del 1 of X2, X3. This is del 2 of X1, X2, del 2 of X1, X3. Now, just a moment. Beta says 3 to 2, right? Yeah, but none of you can see backwards either. So this is a complete disaster. I should never have started this. Del 3 of X1, X2, del 3 of X2, X3. Let's see. In order not to make things even more horrendous, I will write it side by side. So this is X2, this is 0. This is also 0. This is X1, X2 is X1. Del 2 of X2, X3 is X3, and this is X2. Okay, so now let's see. Okay, so it was turned on its side before. Just a moment. X2, 0. X2, 0. Then what is the next line? X1, X3. X1, X3, and the last line 0, X2. Is this even of the right size? No, it is not of the right size. This is 2 by 4. right? So it should have been this way. So it was correct before. Okay, so yeah, so, okay, so I made two mistakes which went against each other. So let me redo this. Okay, this is a very dangerous thing to do without being able to see the whole thing. So this should be del 1. It should be 3 this. Let's see, what should it be? It should have 2 things here and 3 things there. That is what I had before. Why did I? Okay, so 3 things on the side, right? So del 1 of alpha, sorry, beta 1. Del 1 of beta 1. Del 2 of beta 1. Del 3 of beta 1. This is what I had initially, right? Del 1 of beta 2. Del 2 of beta 2. Del 3 of beta 2. This is this beta 1, beta 1, beta 1, beta 2, beta 2, beta 2. Okay. So what is del 1 of beta 1? Del 1 of x1, x2. Del 2 of x1, x2. Del 2 of x1, x3. x1, x2, sorry. This is 2. This is del 1 of x2, x3. Del 2 of x2, x3. Del 3 of x2, x3. So that is equal to x1, x2 is x2. x1, x2 is x1. This is 0. Del 3 of x1, x2 is 0. Del 1 of x2, x3 is 0. This is x3. This is x2. So let's see if this now works out. No, it is not working out. This is a 2x4 matrix. Oh no, it is working out, sorry. Yeah, okay, it is working out. Yeah. I was correct initially, x2, x1, 0. x2, x1, 0. And what's the second row? 0, x3, x2. 0, x3, x2. So that means I get x2, x1 plus, no, x1. 1, 0 times this is x2, x1. 1, 0, 0. This is 0. Then 1, 1. So this is x2. 1, 1 times this is x1 plus x2. 1, 1 times this is x2. Or is this x3? No, x2. 1 minus 1. So this is x2. 1 minus 1, x1 minus. Is this x2 or x3? This is x3. x1 plus x3. x1 minus x3. And this one, 1 minus 1 is minus x2. And the last one, 0, x3 and x2. Is this what I got? No one can check the answer, nor can I. x2, x1, 0. x2, x1, 0. First line works. Second line, x2, x2 plus x1 plus x3, x2. x2, x1 plus x3. Brilliant. The next one I know, x2, x1 minus x3, x2. 0x3 x2, that's the last line. 0x3 x2. So this actually agrees. Okay, so I was doing it correctly the first time, then I thought I had done it wrong, but it was actually correct. So this is the same thing as D at the point x1, x2, x3 of alpha composed with beta. If you did not understand a word of this, that is perfectly fine. Because this is just painful calculation, which is impossible to understand unless you can see the whole thing. And therefore, you will learn it only if you do your own problem, which is going to be an absolute pain. Okay? So now I am, well, I am, what should I say, honorably exempted from people running after an ellipsoid. Yeah, so now what am I going to do? So this actually worked out to my intense surprise. Okay, those of you who are not asleep should applaud. But you were all asleep, so I did not expect to hear anything at all. So, yeah, okay. So this is very painful, but it actually works. Now I will teach you the physicist's way or the engineer's way. I think I would rather. That is the mathematician's way, yes. That has the whole thing completely worked out, but from which you have to extract what the physicist needs. Or what the, okay. So in order to understand what the problem is, this is what you need to know. That 3 in, 2 out, then finally 4 out. So it is good to have okay, now I will have to make up some what is a good example? I did not understand. No, not velocity. We will go back to his example. So food, water,
air, oxygen.
Yeah, food, water, and air going to feces and urine. But I have to have 3 outputs from feces and
4 outputs.
yes.
So-
Okay, so from let's say we have
You have a method that can separate it from urine, water, and urea. So you have urea, water. and
What about vomit?
no. That is no. The inputs, the middle input is feces and urine. So yes, urea and water, and from feces we have to two products from feces.
Organics.
Okay, organic and inorganic material. Okay, so urea, water, organic, inorganic. Okay, so now this is a very peculiar situation. Suppose I wiggle the amount of air and I want to know how will it change the organic matter. So del air of the organic matter. No. That's not the question. I'm not asking you what the value will be. The question is, if I wiggle input number 25, how would output number 72 change? That's the physicist's question.
Well, okay, so.
Is this completely, listen first. Okay, so this is very peculiar. That it's a complicated machine. I wiggle something here and I want to know how some particular thing over there is changing. Okay, so the physicists look at it in this way. So I will use the physicist notation. Okay, so I have 4 things. 4 things. What did we call them? No, it is dangerous in this situation to use 1, 2, 3, 4. Everything will get mixed up. So the output, final output, we shall call. No, just a moment. PQRS. PQRS are the final outputs. Or actually, no. We will call them WXYZ. WXYZ. What came in here, we shall call S and T. That is also a bit dangerous because
The physics, so they don't want you to do anything.
the T is always time. So, but I will ignore that fact now. PQR. Okay, so the physicist will write it in this way. Del Q of X. Okay, so now what you need to know is this. X depends on S and T, right? And S and T in turn depend on P, Q, and R. The physicist will draw this tree, and these are functions basically. So a mathematician would draw it this way. This is beta 1, P, Q, R. This is beta 2, P, Q, R. And this is X is alpha 3, right? These are fed in. This is X is the second one. Second one is alpha 2. Alpha 2. Right? X is alpha 2. So del Q of X, if we look at it, it's quite simple what it will be. X changes because of S. So it will be del S of X. X depends directly on S. That is how what physicists will say. Times the change in S because of P. So del P of S plus del S of X. No, sorry. Yeah, and then yes. Del Q of S plus del S of X del R of S. So this is saying the change in X because of S times the change in S because of P. So you are wiggling Q. Oh, just a moment. I have made a mistake over here. Just a minute. Sorry. I was not looking at my picture. Okay. X changes because of S. And I want to know del Q. So the change in X because of S times the change in S because of Q. Plus, you see, X can also change because of a change in T. And T acts independently of S. So the change in X because of T times the change in Q, change in T because of Q. So this is if you multiply the corresponding rows of the matrix, this is exactly what you will get. Okay, so both are useful because you may not be interested in all the changes from all the sources. Okay, you may be interested exactly in what I just said. If you wiggle one of the inputs, so then you don't need to consider the whole matrix. If you have the whole matrix worked out, you just extract from it the right term in the product. Okay, let me ask if anyone has understood what I did.
Honestly, no.
Okay, good. That's the correct answer.
The same.
Now, do you understand the general scheme of things which is being addressed over here? Even if you don't understand the details. The details you have to work out in private when you are at peace with at least an hour to spare. Otherwise, you will not get this. So there are two machines, and the physicists unfortunately have to deal with situations in which there are 15 machines, one after the other. And then of the inputs that are completely under your control, you wiggle one, and some output from the end machine is of interest. Okay? So then the question is, how does this work out? And then the tree can be much more complicated. So the mathematician always is interested in the global answer. What is the general question and what is the general answer? Then, in particular cases, I should be able to calculate exactly what I need very quickly. So this marks the division between mathematicians and physicists and engineers. The mathematician wants to know the answer in full and doesn't care about the practical applications or the particular answers. The physicist and engineer do care about the particular.
What happened?
Everybody was muted.
Yeah, but I can't hear Bakshi anymore.
He was muted too.
Can you hear me now?
Yes.
Okay, good. The internet connection is unstable. I got a warning and then it actually disconnected. So I'm back on. So you see, let me draw another picture, the physicist picture. So this is we shall call this X and Y, U and V, P, Q, R, S. So I wiggle S a little bit and I want to know how X changes. So the physicist will say, well, X depends on U and V. And U and V in turn depend on P and Q, right? And P and Q in turn depend on R and S. Okay, in this case, if I have functions alpha, beta, gamma, then we are talking about the derivative alpha composed with beta composed with gamma at Rs. Okay? So this is the composite function. So X is equal to alpha composed with beta composed with gamma, 1 of Rs. Okay? So if the physicist wants to know of del X, del S of X, that means how much does X wiggle if you wiggle S? The mathematician would like to know del S of alpha composed with beta composed with gamma 1. the first component of the function. So this is how the two are related. So the physicist's answer to del x, del s, del s of x follows from the diagram. So x changes because of u and v, right? So this should be del s, sorry, del u. Oh, what happened? No. Yeah, can you come here and see? You're not connected?
I'm getting disconnected.
I see. Oh, we have trouble on all fronts. Zoom meeting. Ah, yes, I'm back. Okay. Oh, it didn't. It all disappeared. No. Del. Okay. Okay. X depends on U and V, right? X depends on U and V. So X can change because of changes in U, and X can change because of changes in V. So del U of X, and I can also have del V of X. But U can change because U depends on P and Q. Okay, so that means this will be del P of U. I have to write further down. Del V of X, del P of V. But on the other hand, P can change because of R and S, right? So this would be del R of P. And finally, then there will be another line which would be del U of X, del P of U, del S of P. So X changes because of U changes because of P changes because of R. X changes because of U changes because of P, and P changes because of S. So all the things need to be taken into account. But X changes because of V changes because of P, and P changes because of R. But also X changes because of V changes because of, oh, just a moment. Del P, this is U, this is V. Del P V del S of P. So we have taken into account all the things. U because of P, and P because of R and S. V because of P, and V because of, P because of R and S. But what are we missing over here? We have left out the Q's, right? So there will be another set of terms, which I will not write down, where everything above is, all the P's above are changed to Q's. Okay? So that's the general formula. This is probably easier to get from the tree. But what you should know, that there's no difference between the two, except that if you have the whole thing worked out, you can just multiply the corresponding rows of the matrices and get the final answer. The physicist is interested in just one element of the matrix. But if that is all that you want,
Hello?
Oh, it looks like more internet problems.
Yeah.
He was disconnected. I am the host now. Okay, he's back. He got his host privileges. Tell him that he's muted.
yeah, I'm not muted anymore. Can you hear me?
Yes.
Yes.
Okay. So this is just as painful as it seems. Okay. The physicists don't care about the general formula, and therefore they continue to calculate stuff in a rough and ready manner, and they manage to get the correct answer. But it is important, it is better if you also know how it works. Okay? Your internet connection is unstable. I'm keenly aware of this fact. Okay. Any questions at this stage? It is difficult to bore people more. Yes. They are available not very far from here.
Anyways.
No, all I said was that the hole should be in the shape of a donut. Yes,
Yeah, so
it's a
it'll be sphere with
spherical
hole
object
in it.
with a donut-shaped hole. If you want, I can change the problem. You can do one in which there's a donut-shaped object with many spherical holes.
Are you talking about the thing that's the same shape as a coffee mug?
Well, the donut is in the same, is of course the same shape as a coffee mug. If you define the equivalence classes correctly, that means you can change the donut without tearing so that it acquires the shape of a coffee mug.
What is the radius of the donut?
Obviously, if it has to be a hole inside, I must have a radius of a sufficiently small compared to the.
Yeah, but
I mean, I don't know. It's on the exam. It's on the last exam, 3C. For 3C, there's a solution.
Okay.
For it's not 3C. I mean, exam 2B and exam 2C do have solutions. Okay. It is exam 1C, which is the painful maximum minimum problem, in which I think some people have to analyze 27 different possibilities. And actually, the next one is not that bad. 2A is not bad. 2A, one has to go from the point 0, 0, 0, 0 to the point 1, 1, 1, 1 along distinct piecewise linear paths along the edges of a tesseract, which is a fork group. The different people will have different paths. No two individuals will have the same path. So each will be subject to a distinct amount of pain. Okay.
Are there people that will have more pain than other people?
That depends on their pain threshold. I don't think that the pain is rather randomly distributed and therefore even. So the pieces of the path will be nice. Some pieces will be bad. But the integrals are very simple because they are all just the integral of 1 or t. Incidentally, you should never try to work the integrals out by yourself. You should always look them up in tables. Okay? But you have to show the full calculus. No, you don't need, why would you need a graph? We are interested in exact answers. A graph can never give you an exact answer. Okay? So you have to look them up in tables. It's very rare that there should be something other than a polynomial. Okay?
Professor,
Okay, any questions at this stage?
yes, I have a question.
So again, let me summarize what the nature of the torture. You have two functions that are composed. You can compute the derivatives individually and then multiply to get the derivative of the composite function. You can also first compose and calculate the derivative. These two processes yield the same answer. And there's
Professor,
a process where you have to do.
did you hear Ravi speak? He was trying to ask a question.
It looks like the internet went out again.
Yes, and it has come back.
Yeah.
Can you hear
Yeah,
me now?
Yeah, I can hear
Yes.
you.
Okay. So, yeah. This is the whole purpose of this lecture, which was infinitely boring, is to work out an example in real time so that to see that it actually works. It did. It did, even though in the middle I thought that I had made a mistake, which I actually hadn't.
You look back,
And
believe it's the right thing, and made a mistake, and believe the right, believe the wrong thing, did the right thing.
yes, and did the same thing as I did the first time, which was right. Okay, so this is not, but I mean, the exam is set up in such a way that if you do it slowly and carefully, you will get it right. Okay, so it's not a problem. The next exam, 1C, is a bit tedious. Okay, now I will make an announcement, and you please make an announcement on Discord that there are some people who have not uploaded all the 7 top sheets, and they are in grave danger. And they must therefore upload all the top sheets. And please make the same announcement in 272. Oh, I want to make another announcement about 272 also. In 272, some people did the problem in which one had the nth derivative. And then they checked the solution when n is equal to 4 or n is equal to 5. So I took 3 points off, because if they hadn't checked anything, I would not deduct 3 points, but 1 point. Why did I deduct? What is the proper way to prove something if you do not know the value of n? What irritated me is the fact that they thought that if
Recursion.
you set n is equal to 4 or is equal to 5, that actually establishes that the thing is correct for all n. That, of course,
Don't you need
you
to do
have to have-
induction?
yeah, you have to prove by induction. You have to have a recursive definition and have to prove by induction. Okay, and that they did not do. So this shows why lack of knowledge of 163 acts as an enormous hindrance, because one doesn't know what in fact is correct. So they pretended that it was a proof, but it wasn't a proof. In fact, it exposed what I would call a profound weakness in their understanding. For 1C, no, it was 2C. There was one problem in which one had an nth derivative. Yeah. You got into the class late.
We'll go back to class later, and I moved across the
Yes.
weekend, so I
Yeah.
was happy with what I got done.
Yeah. If you have an nth derivative, then in order to prove that you are right, you would have to prove it by induction. So if you integrate 1 n times in sequence, you get x to the n over n factorial. You have to prove that by induction. So you assume that you have proved it up to a certain value of n, and then you prove that it also holds for the successor value. And then that is the way to establish that sort of thing. I would have been happy if one had not checked, saying that I can't check because I don't know what n is and I have never heard of induction. But to pretend that one has checked something by assigning a value to n, I think shows a profound lack of understanding of how things should be. So not to know something is superior than to talk nonsense. Okay? Now, does anyone have any proof that the balloon that was blown off?
Wait, did it blow up?
Oh, it was blown off.
Yeah.
We didn't, some did. No,
The US Air Force,
yes, that is not me.
that is me. That is we,
No,
that is, I was
It's
talking.
taxpayers' money.
you had no decision-making power
I had no
whatsoever.
decision-making power, but I put in the. liars
You
that probably said that
simply
it was
are an
taxpayers' money.
employee of the organization.
Yes, so we,
So, no,
big Air Force did.
Taxpayers'
the US Air Force did it.
US Air
You
Force.
happen to be employed by the US Air Force. We can't use the word we over here. That would be an incorrect grammar.
Taxpayers' money.
But it is the United States.
No,
The money
we
goes back
all
to the
share,
state.
I mean, all taxpayers share the responsibility.
That's what I'm saying. So we.
No, we still,
USA. USA.
well, one still cannot say we.
Hey,
In other-
shot a gun with
Some group of individuals,
an individual, probably. A single individual.
yes. I mean, I have heard nonsense before, but bravery for shooting a balloon, unmanned balloon, is beyond my imagination as a compliment.
I mean, you have to do something about it.
The only thing that would be worse if it is to shoot an imaginary object and then be called brave. So in other words, if a person who was having hallucinations imagined a balloon and shot it, that would be even worse than this situation. But maybe because the person was having hallucinations, we can, no,
What is the point? Are you not listening to what he's saying?
yes.
He's saying, do we know? I don't know, you never finished.
Here's the sentence.
Yeah.
Does one know? I would never use the word we.
Should I stop the recording?
It's one,
Yeah, please stop the recording.
you